everybody, and welcome back to another episode of Adventures in Machine Learning. I'm your host, Charles Max Wood, and this week we're talking to Qingquan Song. Yeah, I'm not brave enough to try the Chinese name. Sorry. You can tell everybody how it's said and how to find you. But yeah, I was looking at this book, and it looks really interesting as far as like automated machine learning and talking about like Keras and AutoKeras and some of these tools that we haven't really, I don't feel like, dived into on the show yet. So yeah, why don't we just go ahead and let you introduce yourself a little bit further, and then we can dive into what automated machine learning is and how these tools work.
Sure. Thanks for having me here. Thanks, Charles. So my name is Qingquan Song. So you can call me QQ. So I'm currently a final year PhD student in Texas A&M University. So after my graduation, I will become a machine learning and relevance engineer in LinkedIn. And this book is collaborative with many publications. So it's written with my lab mate Haifeng, who is the first author of AutoKeras, which is AutoML, the most popular automated deep learning tool currently, and also with my advisor, Dr. Xia Hu. Yeah, so should I provide more introduction for the book, or we can?
Nope, that's good. We'll put a link to it on the Manning website. We also have discount codes, and I'll make sure that that's in the show notes because I can't remember which one to use. They've given me like 3, so.
Oh, really? Oh,
yeah.
Cool. Yeah, currently the book is on MIP. So there are like 5 main chapters and 2 appendices out. And there are 4 remaining chapters, which will be released probably half a month per chapter. Yeah.
Nice.
Did you work your tail off to get that senior developer gig just to realize that senior dev doesn't actually mean dream job? I've been there too. My first senior developer job was at a place where all of our triumphs were the bosses and all the failures were ours. The second one was a great place to continue to learn and grow, only for it to go under due to poor management. And now I get job offers from great places to work all the time. Not only that, but the last job interview I actually sat in was a discussion about how much my podcast had helped the people interviewing me. If you're looking for a way to get into your dream job, then join our Dev Heroes Accelerator. Not only will we help you get the kind of exposure that makes you attractive to your dream employer, but you'll be able to ask them for top dollar as well. Check it out at devheroesaccelerator.com.
Well, let's just dive in and start talking about these tools and what AutoML is. Now, I'm kind of new to the machine learning arena. I had some co-hosts who were working out scheduling, and so I've just been doing these on my own, who are much more practiced at this. So for me being new, can you kind of explain, and I'm sure there are other people who are listening who are also new, what AutoML is? And we'll just start there, and then we can dive into what the tools do and how they come together.
Sure, of course. So first, I need to, since I'm not sure if everybody already know about machine learning, so I think before the experience of machine learning, the general AI is mainly use the symbolic AI, which means we provide the rules for the machines, and the machine can, based on the rules, to detect or predict something. So for example, if we want to recognize the image, so you have to provide the machine like maybe the color of an apple is red and the color of some banana is yellow or something like this. And the machine can, based on this, to directly recognize something. So this is called like symbolic AI. But with machine learning, you don't have to provide the rules explicitly. You can provide the data to the machine, and then the machine can learn from the data about these rules. And then based on the rules, the machine can predict something or detect something. And so in machine learning, there are some parameters which we want to learn. These parameters we'll use to memorize the rules from the data. And there are also something called hyperparameter, which is some predefined parameter by human, and it is not changeable during this learning process. And this is called hyperparameter. And for automated machine learning, so the main task is to some people may not have enough background to define this hyperparameter. So for AutoML, we want to automatically assign the suitable hyperparameters so that the people who does not have enough background, they don't have to choose by themselves, what kind of models we want to use and what kind of hyperparameters for each model we want to assign. So that's the thing. And also there are a lot of stages in machine learning. You have to pre-process the data, you have to choose a model.
Right.
Yeah, you have to deploy the model. So if you use AutoML, so some of these efforts can be removed. You don't have to you can directly provide the raw data, and the AutoML will choose a suitable way to preprocess it and choose a suitable model for you, and then tune the model and help you to like even deploy the model. So that's what AutoML can help.
It's kind of interesting because we typically think of machine learning systems as systems that make decisions, right? They classify things, other things like that, and more like science fiction-y AI. They're like making these broader decisions, and so it almost feels like it's kind of a meta layer of AI on top of AI to a certain degree.
Yeah, so like AutoML is still a subfield of machine learning, but it's kind of to help you use machine learning rather than give you some machine learning models and help you to use it. Yeah, so the goal.
So how did you get into AutoML as opposed to some of the other areas within machine learning?
So I think I get into AutoML in my second year of PhD study. So at that time, we have a project, mainly it's the DARPA project. It's called D3M. It's data-driven discovery of models. So in that project, there are a lot of universities collaborate with each other. So we try to propose some automated machine learning tools. Like we compete with each other and collaborate with each other. So mainly because of that project, so I know something about AutoML. And then we start to do something called neural architecture search. So this is something related to automated deep learning, because in recent years, so deep learning is quite popular. And so it's kind of dominant in machine learning area. But deep learning has a problem. So deep learning has even much more hyperparameters we need to assign for the model. So like they have a bunch of models, and for the neural network, you have a lot of things to set. And this is quite difficult to democratize AI. So for the people who does not have machine learning background, or even for the expertise, it is hard for them to tune the model. So at that time, so people like try to think about if we can use AutoML to try to tune these hyperparameters and help people to use deep learning easily. So we try to like go delve into the automated machine learning area.
Yeah, that makes sense. I'm a little curious as we dive into this. If somebody just doesn't have any experience whatsoever, what do they need to know in order to use this?
I would say that, that's a very good question. So in fact, for AutoML, it's targeted on two part of the people. The first part is that people who does not have much expertise. They may not even know any of the machine learning models. So that's the ideal case. So they want to use, but they don't know anything. So they have the data and they have the task. So what they have to do is just provide the data to the AutoML system and tell the system what you want to do. For example, I want to do a classification. I want to classify the data. I want to do for example, image recognition or like anomaly detection or these kind of or recommendation, these tasks. And then the machine can directly provide a model. So, and you may not know what the model is, but this model can help you to do this. So after that, you can provide the data, and then the model can help you do the task. So in this case, you don't have to know, I would say you have to know very few of machine learning knowledge, such as what kind of machine learning task you want to do. At least you have to know the task, and you have to provide the data to the machine. And then you don't have to learn other things. But AutoML is also targeting on another group of people. They have enough expertise, and they know what kind of model they want to use, or they have some choices for the models, and they just don't know which is the best one they want to use. And in that case, you have to have enough machine learning background. You have to know maybe what kind of models are good for your task. And you don't have to know much about the tuning of these models, but you can provide your choices to the machine, and the machine can help you to further discover the optimal one. So in that case, you have to have more expertise for these things. And also for the last part of people, I would say that they are the people who build up machine AutoML system. So in that case, you have to know everything. If you want to build up this AutoML system, you have to know everything, and you also maybe want to know some interpretations of the models. Yeah, that's the case. Yeah.
So it sounds like it works better on problems or approaches or data sets that are already somewhat understood, right? So you talked about like classifications and recommendation engines and things like that, right? Where there's already something there, AutoML, it sounds like works in those situations. If you've just got some completely wacko off the wall thing that nobody's really seen before, I can't imagine that there are too many areas that we haven't explored yet. But imagine somebody runs across something where, their data set's really wacky and the problem they're trying to solve is a little bit unique.
Yes.
Does this work there too?
I think this is a very good question. It's kind of a limitation of AutoML now, because AutoML, ideally we wanted to do everything. So we want to have an AutoML system. When whatever data set or task you provide, it can directly provide the model. But currently, I don't think an AutoML system can do so. Maybe in the future it will. But currently, there are some people who targeting on like task-specific AutoML. It means like there are some popular tasks like a recommendation or like another action. So we tailor the AutoML system to these tasks so that the AutoML can generate the corresponding like more tailored model for these tasks. So because in different tasks, we often have different type of models. So we have many models for each task and for the various task to task. So that's why there are some people working on like AutoML for a task-specific AutoML. And if you have a really weird task, I would say that the target should be like clarified, should be explicit. Like for them, you want to do classification, you want to do regression. So these tasks should be clarified. But the data have to be like in the one of the format that the AutoML system can accept. Like it could be a table, it could be like a Python processed matrix or some other things. At least the system can accept the task or some JSON files or TXT files, these kind of things. So the AutoML system should be able to accept this data. So then it should be fine. But definitely if your data is too noisy, it's too weird, so you have to pre-process by yourself first and then provide to the system.
Right. Makes sense. So I'm kind of going back and forth between talking about more of the approach or talking about the tools. Let's talk about the tools first.
Sure.
So you've got, because I think the approach will kind of come out of that. So you've got AutoKeras, Keras tuners. AutoKeras, it looks like you actually are one of the folks that works on it.
Yes.
Do you want to just explain what it is, what it does, and how it works?
Sure. Of course. So I think maybe the audience may not know like AutoKeras, but they should know like Keras probably, or TensorFlow. Like TensorFlow, so in fact, these four tools, like TensorFlow, Keras Tuner, and AutoKeras, these four are within an ecosystem. So they are called Keras ecosystem. So the most fundamental one is TensorFlow. So TensorFlow provides you the tensor operations and basic mathematical calculations. So it's the fundamental. And beyond that, there's Keras. So Keras is mainly like an API to help you better use like TensorFlow models for deep learning and create TensorFlow models and deploy them. And Keras currently is part of the module in TensorFlow. Is in TensorFlow 2.0 is already incorporated. So Keras is merged into TensorFlow. And beyond Keras, so Keras is kind of help you to build deep learning models, but you still have to know how to build it and tune it. Like for Keras Tuner, it's kind of hyperparameter tuning for Keras models. So you can use Keras Tuner to tune the hyperparameters of Keras models. And also you can even tune something beyond deep learning models. You can even tune like scikit-learn, like some base shallow models, like regression or tree models or these kind of things. So that's Keras Tuner. And on top of this ecosystem, it's called AutoKeras. So AutoKeras is like have several APIs. It's based on the Keras Tuner. It can also help you to tune the deep learning models, but in a more easy way. So when you use Keras Tuner to tune the deep learning models, you still have to create the deep learning models one by one, but you can provide a space, like the choices for each hyperparameter, like how many layers of the neural network you want to use. And then the Keras Tuner can help you to choose it. But for AutoKeras, you don't have to provide these things explicitly. So there are several APIs. So in the one API is called Task API. So the functionality is like what I explained previously. It's like you provide the data, you provide the task, then I will directly give you a deep learning model. You may not know what kind of model it is, but you will achieve a model to help you do the task. And also, if you are some advanced users, you can use some other a little bit lower level API to help you to customize your search space and even your search algorithms. But generally, the goal of AutoKeras is to save your efforts, building these search spaces, and can directly provide you a deep learning model after you give the data. So that's the ecosystem of Keras. Yeah.
So then your approach is essentially just to use one of these tools, right? You put one of these tools on your model and let it do its thing?
Mainly this book is try to still introduce the general AutoML concept and also the algorithms, but we'll use these tools as the examples to help you to better understand this. And we first introduced the task API of AutoKeras. So in that case, you can use 3 to 5 lines of code to solve the problem. But at that time, you don't know what kind of models you are searched from and what kind of final models you achieve. And then we will teach you how to define the search space, how to use Keras Tuner mainly to help you to make a more customized choices for your selection. And and also for some shadow models. And after that, you will learn to so we'll have some AutoML algorithms. These algorithms help you to search the models. You are you will try to understand what kind of ways we use to search the models from the search space. And then we will teach something about parallel or distributed things. Since AutoML are not just for small problems, it may also have a lot of data and even tasks or something. So you may have to learn something about dealing with the large-scale data set or large-scale models. Yeah, so that's kind of the outline of the book and how we use the tools to help understand the AutoML concept.
Yeah, that makes sense. So I'm trying to figure out too, where people are using this. Do you have a good sense of where people are implementing AutoML?
I would say there are two groups of people still. One is in the academic part, so in the research community. So mainly in the university. So we don't have enough computational resources in the university mainly compared to the company part. So we try to build AutoML mainly from the algorithm side or understand the underlying theory or foundations of AutoML. So we build some open source tools like AutoKeras, or there are some others like AutoPyTorch, or these kind of tools, or AutoScikit-learn, so these kind of tools. And so mainly they are dealing with small scale problems. So, and they can be used for a research topic and compare with other models, or target on a Kaggle data set, or dealing with some Kaggle computations. And I think there are another group of people, mainly in the company. Most of the companies, I think, provide AutoML services. They are cloud services, like Google, Microsoft, and Amazon. They all have their AutoML tools, and they provide cloud services for this. And they can help the middle level, I would say the middle scale companies or small companies to generate some machine learning models based on AutoML to them. And there are some commercial ones, there are some non-commercial ones. Like Google, they have the commercial ones, and they also have the non-commercial ones, which I think probably you can find it on the Kaggle also to use it. But that one can only deal with, I would say, since the computational resources provided to the non-commercial AutoML is still limited, so you cannot do much with it. But for the commercial ones, definitely you can work on some larger data sets. And also there are some internal tools. I think for Google, for example, they have Vizier. There's a system which is in the published paper of KDD. So it's kind of internal tools, AutoML tools, to tune their models. Yeah, so that's the thing. They've already something that have already been deployed in the companies. And also, I think there are some AutoML tools help, like Disney provide a foundation or search. I kind of forgot that. And also, there are something you may have known like AlphaGo. That AlphaGo, there are some when they create AlphaGo models they also use AutoML to tune the hyperparameters of the growth system. Yeah, so that's something I can think of that has been used in the company or also in the research academia.
Very cool. Now, is this something that you can use to kind of manage end-to-end systems? Because I've talked to some people where they have something that goes through like one algorithm or one system and then goes through kind of a pipeline. Do you use this on specific stages within the pipeline or can you use it on the whole thing?
Oh, yeah. That's like depends on your requirement and your expertise. So like use AutoKeras as an example. So the higher level API can help you to directly provide all the blocks in the pipeline, like the data preprocessing, feature engineering, the model selection, and then the final thing, the post-processing or something. And the second level API is like you choose the blocks you want to use. Like for the preprocessing, you define a block, and then I will tune this block. For model selection, maybe you have a fixed model you don't want to tune. Then you can just connect this block with your preprocessing block. So the system will only tune the preprocessing part. And also you can define other part you want to tune or you don't want to tune. And for AutoKeras, currently we haven't provided some visualization tools. We only provide you can like directly see the final results. But I think in the future, there'll be more like visualization or something that can help you to interpret your results. Like after the search, you can directly visualize what things I discovered and what kind of things I searched during the search process. And you can better like choose these modules or understand the results, why the model can give like better results than what I tuned. So that's something, you may want to use.
Right. Yeah, it sounds like you can use this to get better results. I'm wondering how you verify that you're getting better results because in a lot of these cases, for example, just to throw another situation out there like COVID-19, right? People have been talking about how they measure certain things or how they get certain results in the numbers. And so I've kind of been looking at it and looking at how politics has injected itself into it. Yes. I'm starting to realize that raises some questions about some of the numbers, right? And I'm not making any kind of political statement here, but what I am interested in is, okay, then how do we verify the numbers, right?
Yeah.
How do we verify that this hasn't been twisted or that there's not something in this system that is giving us incorrect, or I don't want to say like completely false because it's usually not. Usually it's somewhat close to the truth, but it's inaccurate. That's the word I was looking for, inaccurate. So how do we measure that with these systems to know that AutoML is actually getting us closer to the information or closer to the outcome we want as opposed to further away? I mean, sometimes you can just look at it and you're kind of like, that this outcome's better than that, but sometimes it's hard to know.
Mm-hmm. Yes. I think that's like, there are some metrics. Of course, mainly they are machine learning metrics. So the first one is like, of course, the accuracy or something. So in fact, before you deploy the model, you don't really know how it works in reality. You can only based on your data, your current collected data, and you can split part of the data for training, evaluation, and testing. You won't touch the test set before you get the final model. And you are based on this test data to test the accuracy, such as the prediction accuracy or some arrows you want to choose, you may use to measure this. And another measurement could be like the complexity, like the time, how fast is the machine, because sometimes in the recommendation or other task, it's very important, like the latency of the system. But I would say for the medical task, for example, the COVID test, it's kind of tricky. It's kind of a different thing. The accuracy is important. Usually in medical tasks, we don't have too much data. So for the complexity, it's not a very big problem. But there are some interpretation ability and also the transparency or privacy of this is more important to measure. Because even you provide a more accurate model on the test data, people may not trust it because it's still a machine model. People still want to trust the doctor. So in that case, you have to provide some interpretations why a model is better. And not only based on the accuracy, but also based on some features that people can understand. So
that makes complete sense.
Yeah. So in that case, we need some interpretations for this. So for current AutoML system, I don't think there are too much research on this, but it's a very popular, and I would say it's kind of would become a very good research topic, like how to interpret your AutoML results. Like like not only like post hoc, like after you got the model, I can use some interpretation method to interpret why this model can do better, but also like the middle, in the middle of the search process. So during the searching, why this AutoML system provide this model rather than that one. So that's kind of a good interpretation that may help people to understand why the model is chooses and why these things can provide it. I think there are maybe some commercial systems, they already provide some of the visualizations. Like after the search process, I will use some interpretation tools to detect what feature is more important for the final predictions, for the model to do the final predictions. So this is kind of interpretation that we want to have to better convince people this AutoML system or this model works. And also for something like transparency or privacy. So usually these things is to like protect the data of protect the data we want to use, and also to provide the people more like transparency, like how we use this data. We do not like affect your privacy, or we do not use some side information. So in that case, there are a topic called federated machine learning or federated automated machine learning. So for federated machine learning, it's like you collect the data from the devices, but you do not upload the data to the cloud. You just try to upload some gradient information or something that is needed to help train the model, but not the original data. So in that case, the AutoML system can in fact, the machine learning system can base on this information to train it, and the AutoML system can also base on this information to tune it and to help provide a better results while protecting this privacy. So these are another thing that like people may want to use to measure the effectiveness of the machine learning system or AutoML system.
Yeah, that makes sense.
Hey folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Yeah, because you're talking about privacy and yeah, I mean, all of these concerns are things that you really can't violate. But at the same time, you also want to make it explainable, as you were saying before, because if it's a black box that's just spitting out an answer, it feels like sometimes other places give us that too, right? It's like, hey, this is the way it is. And it's like, well, why? And I tend to trust the sources that can tell me why, even if the other answer is a better answer, right? Because I can understand the answer I'm getting. And so, yeah, all of this makes really good sense. Do these tools help with that explainability or help with that stuff? Or are we into some of the other tools that we've talked about earlier on this show?
I think for the current AutoML tools, it's usually in the academic area. I don't think there are too many tools who have this kind of functionalities. But for companies, usually they provide some visualizations for the final results. And I mean, this is only for AutoML, but for the interpretation of machine learning, there are a lot of tools to help you understand. Like in our group, we have a very important topic called interpretable machine learning. So we have a lot of members working on this, and we have a lot of tools and surveys to help interpret the model. So in fact, these tools can be also used in AutoML, like to help interpret the results of AutoML. So mainly after we got a model, we put the model into the tools, and the tools can provide that, okay, which features this model think is most important to give the prediction. So this is something that the interpretable tools can give you, either from visualization or from some numbers like the feature importance or these things.
Yeah, we've talked about some of the tools that kind of interpret some of the algorithms and stuff for you on previous episodes. But yeah, it's good to know too that, and then it kind of felt that way when you were talking about it, that this is kind of at a different layer. And so you can just kind of stack them together to see what you're getting from the overall system without having it necessarily conflict with those, right? This is a tool that actually just either helps you set up or optimize your current systems. and make those algorithms work for you.
Yes. And also we probably want the tools can also help us to better use this autonomous system. So maybe like later after we like create a search space and let the autonomous algorithm explore from it, and the interpretable tools can give us some intermediate feedback. And then we can know that some part of the models is kind of useless, so we don't have to explore too much of this part, and we can let the machine to explore some other parts. And then we can try to like change a little bit to help the autonomous system to do it faster. So this is like a collaboration between the autonomous system and the people who use it. So it's like a interactive process.
Yep. Cool. So I guess my last question that I'm thinking of is, and we talked about kind of verifying the results, but is there a way to kind of test to make sure that it's doing what you want it to, other than just doing the interpretation of the results? I guess. So in other software areas, we actually write unit tests and things like that, right? And so I guess that's what I'm wondering is, not necessarily is it giving us better results, but just is it working as expected? Is there a way to actually test or know that?
I think for the people like us to build up the autonomous system, we also need to write the unit test, and also we need to write the integration test. And these kind of tests are all needed. So during the writing of the autonomous system, because I think like one simple thing is like the seed, like the randomness. So because when you do AutoML, you would face with a lot of randomness. First you have to fix this, and you have to know that, and then you will know that if it works as you expected. Like you can like explore the search space and see if it really like for example, you can create a very small, tiny search space, and you know that which model performed the best on it, and you let the autonomous system to search from it and then discover it, and then you will know that okay, this autonomous system can discover the optimal model as we expected, like within a few trials, like within limited time. And I think this is mainly the issue that the autonomous system builder should think about. So we have to write enough tests to thoroughly test the system. But for the autonomous users, I think usually they won't like care so much. They will trust the autonomous system, since it's hard for you to touch too many things of this system, because if you already want, so AutoML kind of sacrifice something to help you to do it more efficiently. It kind of sacrifice the flexibility for you to like customize everything. It's still like it helps you to release the burden, but kind of sacrifice some of the flexibility, I would say. So in that case, you probably can only test the accuracy of the final model you retrieved from the system based on some measurement of machine learning. And for the testing part, I think that's probably the main thing you can use to test. And that's why I think the transparency of autonomous system is more important.
Yep, absolutely. Yeah, because if it's transparent, then you can it becomes easier to evaluate. All right. Well, let's talk about your book for a minute. So, what's the story behind that? Did Manning come and beg you, or really beg you to come write the book?
I think in fact Manning reached out to my advisor to see if we have something. Since we are the creator of AutoKeras,
right?
They want us to try to if we can write something about AutoKeras to teach AutoML, and then we kind of expand the topic a little bit to not only focus on AutoKeras, but also focusing on the AutoML in action. It's like a practical way of using general AutoML, and use AutoKeras and Keras Tuner as examples. And Haifeng, which is the second author of the book, he's the first author of the AutoKeras package, and he's going to join Google, and he worked in Google for 2 summer internship, and to collaborate with like Francois, who is the author of Keras. I think this helps a lot because currently we collaborate with Google to work on AutoKeras, and they provide us a lot of guidance and put AutoKeras as part of the Keras ecosystem, so that it helps a lot for us to contribute to like work on the book. So, and Haifeng will he like kind of know more about Keras Tuner and work on Keras Tuner, so that we can not only use Keras but also use like AutoKeras to Keras Tuner to like give better examples in the book.
Awesome.
Yeah, it's kind of a long period because it's have been like 1.5 years to work on the book due to the COVID. It's kind of affect the
the
process.
Yeah, well, I've written a book and it's work. It's real work. And especially what I found was that there were periods where I didn't have any time to work on it. And then there were periods where I had a lot of time to work on it. And so you just kind of have, you get the updates in as you can. So that makes total sense. Congrats to your co-author too on getting hired at Google. That sounds really, really interesting. If people want to reach out to you and have other questions or want to kind of follow what's going on after you graduate with your PhD, where can they find you online?
I have my homepage, and you can also find me on my LinkedIn page. And of course, you can find me from my advisor's page. Mm-hmm. And if definitely, I think the best choice is to search automated machine learning in action on Manning and to look at the book. And then based on the book, you can find me. Definitely, you just search my name on Google. And I'm not sure if there are like some author homepage linked on the website, but definitely you can find us from the homepage of the book. And I think that's the best choice, because I would highly recommend to you to look at the book first, or like purchase the book and comment on the book. And then go to our homepage to see the new stuffs or some papers or some further readings of this.
All right, sounds good. Yeah, if you can get me those websites, I will put them on the show notes. On Manning, unfortunately, on their website, your names do not.
It's not linked.
They don't link through to anywhere. So if somebody wanted to find you that way, I think they'd have a little bit of a hard time. But we'll definitely put that out there, because I love it when people connect with our guests and let them know what they appreciated, and then also ask more deep and probing questions. We've actually had people back on because it was like, hey, I had a whole bunch of people ask me these questions, and you want to do another round? And those are some of the best ones. So let's definitely do that. Hopefully people get in touch with you.
Hey folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams, or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming, and I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit. And you can find that at summit.mostvaluable.dev.
The last segment of the show is picks, and it's just shout outs about stuff that you've been enjoying. I'm assuming as a PhD student, you don't watch a ton of TV, but people generally pick kind of pop culture stuff that they're enjoying, so that's like TV, books, movies, things like that. People also pick technical things. So if there's some technical thing that's making your life better, we'd love to hear about that and just stuff like that. I'm going to go ahead and throw a few out, and then we'll just kind of see where things go from there. One thing that I'm going to pick is a book, and this book is a business book. And I know that most people here are doing machine learning. They're probably either dabbling in it in their spare time, or they're doing it for work at a company that needs it for one thing or another. So this is more kind of management and business. But the book is called Who Not How, and it talks about when you have a problem to solve, and usually it's not like a programming problem, right? Because in my case it is, but most people it's not. It's not how am I going to solve this? It's who am I going to find to solve this, right? And what I found is that it's very empowering to get stuff done, right? Because I can take a step back and say, okay, I don't have time for another thing, right? And that's generally true of my life. I don't have time for another thing. And so then it's who, not how, right? It's not how am I going to cram this in or how am I going to get this problem solved? It's who am I going to find to do it. And so I'm going to pick the book. It's by Dr. Benjamin Hardy and Dan Sullivan. Sorry, I said that wrong. And anyway, I'm really digging it. It's a book that I'm reading for a group of guys that I get together with on a regular basis. One other thing that I'm going to pick, and this is kind of it. So I have two more things, and they're both related. One is 2 days ago, as we record this, it's May 7th, was the 10th anniversary of us recording Ruby Rogues, the first episode of Ruby Rogues, which is the longest running show on devchat.tv, which is the podcast network that we run here. And, there were 5 of us on the call, kind of turned into something pretty major within the Ruby community. And it spawned all this other stuff, right? So we started a JavaScript show and then a freelancing show and then an Angular show and then an iOS show. Actually, I think the iOS show was first, but then we started a bunch of other shows. And at one point, I think we were running like 19 or 20 shows that were coming out every week. But it was 10 years ago where that started. That wasn't the beginning of my podcasting journey, but it was the beginning of what we now call devchat.tv. And so that has been really fun to just kind of go back and look at where things were and how things have come around over the last several years. The other thing that has been really interesting related to that is I've kind of been thinking back on the last 10 years or more. I've been podcasting for about 13 years and just that journey, right? And so some of the stuff I'm very, very proud of. And some of the stuff I'm very, very not proud of, right? There are some things that I really, really, really screwed up. Most of the stuff that I screwed up that I'm somewhat not proud of is just kind of, I could have done that better, right? I could have built this better. I could have put this together better, blah, blah, blah. The stuff that I deeply regret is the personal stuff, right? It's the people whose relationships I damaged or worse, right? One in particular I'm thinking of, I pretty much nuked it. And I'm not quite sure how to recover that. But I guess what I'm picking is just taking a minute to think back, okay, how did I get here, right? What was the path? What was the journey? And then think about, okay, what went right? What went wrong? We call it a retrospective in programming. But at this point, with at least the one that I kind of scorched earth, nuked, at the time I didn't understand the damage I was doing. And now I'm trying to figure out how to make it right. And it's just been this interesting process of, hey, I've come a long way, right? Nuked it about 5 years ago, and I've come a long way. And at this point, those relationships really matter. And so I'm also going to encourage people to have a little bit of empathy. And it's not necessarily always a natural state, but just think about, hey, what's it like to be the other person in this situation, right? And I justify things to the hilt, and it happens. But yeah, just thinking about that and realizing, but from the other perspective, I can understand why this hurt feelings. So anyway, it just kind of got me a little bit nostalgic and made me really think about that stuff. And so, I'm trying to decide what to do with it, because 13 years of podcasting kind of makes me want to just write out the story somewhere or tell the story on a series of videos or something. But I don't know. Anyway, in the meantime, I'm kind of reaching out to some of the folks that have been part of this journey and just either rekindling a relationship that's just kind of disappeared because we just haven't talked, all the way back to, hey, I kind of screwed this up and can we fix it? So anyway, those are my picks. QQ, what are your picks?
I think for me, it's like, since I'm still pretty young, so I just graduated from my PhD, so I don't have too much things to share, because this is like maybe most of the audience, I think also for you, you are much more experienced than me, so you have more things to share. I think what I can think of as is just something that I can remind in my PhD study. So this is just something I can pick from that. It's like some of the words that I learned. So one is like definitely is working with a team is better than working individually. So that's the first thing I think of, because everything I work during my PhD study is not working alone. It's guided by my advisor, work together with my lab mates and also other colleagues. And also the second thing is like I think focus on one thing at a time is more important than focusing on a lot of things jointly. It's like although these things might be kind of useless now, but in the future it will be useful. But you probably want to work on one big thing at a time. So not like working on a lot of side things. So like for the book, we work on like 1.5 years. And during that time, I don't have a lot of other contributions or other stuffs in the research aspect, but I think it's very important. And the last thing is like my advisor always say, like work hard and play harder. So it's like you have to like maximize your personal happiness and wellness rather than just like work. Like you should have the passion to work, but you should also balance this with your like personal happiness. So that's and maybe last thing is like you try to learn from others. Like just like I don't quite read a lot of other people's books, and also I didn't know much about this kind of what kind of things I should pick. But I think this kind of process is kind of a way to think others' feedback and learn from others. So I would hear more after this podcast. I think later I would like to hear more about people who join this podcast, what they learned, and also learn from you. And I think you said you have like collect these things to like create a book for these things, or to like summarize these things.
Yeah. So my thinking was just to put my own story out there, but it would be more around podcasting and influencing tech.
Sure. I think I would be very happy to learn from your experience. And got some feedback. Thank you.
Yeah, as far as that goes, I do have a show about that where I tell some of my backstory, and that's at devinfluencers.com/podcast. And we go into that. I also have an accelerator. I was promoting it for a while. I've kind of backed off on that a little bit. There's probably an ad in this show for it. But I've actually been coaching developers on becoming those kinds of influencers and starting podcasts and things like that, and been helping them work through the process, because I feel like the dev community at large needs more voices out there putting out good content to help bring people up and increase not only the skill level, but the satisfaction that people have in the work that they do. So, yeah. But yeah, if you're looking for that kind of a thing, that's where that's going to be found. And yeah, but thanks for coming. This was really cool. Congrats on graduating. I guess I should be calling you doctor.
Thank you for having me.
Yep. All right. Well, we're going to go ahead and wrap up. And until next time, folks, Max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.